Welcome to a new test and teardown video. This time I'm going to cover 3 products from Wilcom in one video, just because it's faster and easier that way. So one is a range finder, or it's an optical fault locator. The other one is a traffic detector, and the first one is just a signal beacon, also used for fault identification. Check out if you got tons of fibers and you want to know which one's connected to which one and all that kind of stuff. You can just screw this onto your cable, turn it on, and you'll be able to see where the signal go. You can also use it for fault detection and all that kind of stuff. This one is also from Wilcom, and the type number is F6230. In this big package of everything, I also got all the paperwork and all that kind of stuff. There was a little flyer here with this pen style fault locator. So it cost $280 for this unit, and it is from so it's 23 years old. I got the original package and all that kind of stuff. A nice foamy thing, manual, operating instructions and all that kind of stuff. So it is calibrated to an exact output power, and that is of course what makes it so expensive. And it's also really, really beautifully made in aluminium, and the way that the click and the feel is just fantastic. Output is in CV constant or in 1 Hz mode, then it just go blink blink, and of course if I take my finger here, you can see there's output, right? So let's try and test the other one, because I need this one to test the other one. That's kind of the little trick here. So the next unit is the optical fiber identifier. I took off the battery compartment lid. Look at that. Milled aluminium, super good quality. I really like the build level for this unit. And then there's of course a 9-volt battery, and there's a little springy thing here that holds it real good and tight. And when you turn this up here, let me turn off the light, then it goes on, and then it's measuring power in each direction. See, if I hold one side, and then we get a little bit of backlight in here, or if I do it the other way, see, then you can see the direction. So it detects light in different directions, and the idea is you take your fiber. Okay, now we can turn on the light again. The idea is you take your fiber and you just bend it a little bit up in this curve, and then we got 2 sensors that will detect the light that escapes from either side, and that will reveal the data direction, so you know what side traffic is coming from. It's also saying what kind of modulation frequency you got, and it actually also works with this test laser. So let me try and turn this into CV mode. See? And data goes that way, and it actually goes all the way to, if I can hit this hole. So I really believe this unit works. Oh, let me show you. We got, I don't know, 3 ICs in here, and under that one we got even more. It's full of electronics. but there isn't, as you can see, this is more or less designed like an apple. You know, no screws, nothing to see, so you need to know exactly how to take it apart. There's probably a little hidden trick. I don't want to destroy anything, but it's probably something with holding this and then do a little clickety thingy. Just too bad, because I really don't want to break it. The idea is also you can take away the fiber bend tool, and then you can look in the little carrying case and you'll find other different fiber bending tools for different types of fibers. So it's actually really nice. But there's one last thing I want to show you, because I got that one as well, and also this one is 23 years old as well, and back then it was $2,500. Oy, oy, oy. That is a lot of money, isn't it? But of course it's also super nice. Let me show you the complete assembled unit. Click and then you lift it up. Oh, that is beautiful. And the last one is the distance to fold. I also got, nobody fill out this. We got the information about here, its age, so it's from 1999, so it's also 23, 24 years old. And it shows all about the meters. The thing is, this one only measures from 30 meters. I think it was, where did I find it? Here. So, see, minimum distance is 30 meters. And I haven't got a cable that long, so I really can't test if it's working or anything. We've got pulse width and pulse rate. And, oh yeah, it says something about index of, no, yeah, okay, here it was. Plus minus 2 meters, and it can actually measure all the way up to, was it 10 kilometers or something like that. And there's actually a really cool thing about this. If you got multiple like bends or half cracks or some quality problems with your cable, it can show multiple events. I think it was up to 7 events if there is enough signal that goes to the next branch, obviously, right? So it is quite amazing. Oh yeah, take a cable and then verify the length and blah 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 blah. Boring, boring, boring. All we want to do is actually power it up. But what I already did, I took away the battery compartment because of course it didn't power up and I didn't see any connectors at all. So at the beginning I actually took away all the 4 screws because I couldn't figure out, is this a battery compartment or what is this, because it was hidden that well, the way that it closed it was closed really nice. So here's the battery compartment, but what do you see here? We got the white goop going on right there. So if I take out that, see, that can't be good. And I don't want this to go inside the unit, so I'll have to go in super clean mode now. So that went very well with the cleaning. I mean, it really looks like it's new again. Wow, that was great. So now we can have a little look inside this unit. Have to be very, very careful. As you can see here, we got very, very thin fibers going all over the place here, right? goes up and down and in here. And that is because I don't know if I dare to take those fibers out of this, but there's a combiner, and then we got one fiber that goes over to this unit, and then two fibers come out. So in here it combines two fibers with one, and then the two fibers goes, let me show you guys this, a detector and an emitter. So that is what it's doing, right? It is absolutely beautiful. Got some power supply down here where the battery is coming in, and then the rest is software. What is that? ISP, in-circuit serial programming for this part, and then the other one is probably also some fancy smancy programmable. Oh, look at that. So it's designed by Orchard Technologies Engineering and Consulting Incorporated in 1999. Absolutely. Huh. Look at that. That is one of those Max 232s. Some capacitors and stuff. And then you'll have a serial port or USB. There's probably a little USB chip there with a little crystal, right? For some sort of a connectivity kind of things. Yeah, that will be the detector. I bet that is a detector and a little op amp and stuff like that. Oh, we got some more op amps. And down here, that will be the emitter. And that is a power transistor and a pulse generator for the emitter. Oh, the fibers, they're just so thin. It's almost like a hair. I don't know how well this is picked up by the camera, but they're like really, really thin. So let's just carefully put this back together. And let's try and power it up. Put some batteries in. So to be able to detect 1300 nanometers of really badass infrared, I cut a transistor like this and I biased it and all that kind of stuff. And yes, it is indeed light sensitive and all that kind of stuff, and then I just put it all the way in the connector like that, and then I hit measure, and then it will turn on laser. This is laser active, and it's just measuring for a quarter of a second or something like that, and then it will send out some pulses, and I don't measure anything at all on my scope. This is just the background noise. I gained it up and I'm now in AC mode and all that kind of stuff, but I don't see anything at all. So maybe this is not the way to detect this. Damn it. So I tried another approach, LDR. So a tiny little LDR like this that more or less fits inside the connector. And then I just hold it. Ah, damn it. I just hold it like this, right? And then I've set the trigger just below where nothing happens, and then I hit the measure. And then, come on. This is because I just bent the detector. But before I saw some pulses and stuff, so I think it actually works. Send out some pulses. If this is, how the heck? Why don't I have a badass 1300 nanometer detector that actually is nice and reliable. Let's try again. And when is it sending out some... Oh man, I'm pushing, sending here and there. So here is this background stuff, and then I hit measure. And then it... Maybe it's not doing a whole lot all the time or stuff. I don't know. So I will just say, well, it is just beyond what I can measure, or it's not working, or is it working? I don't know. Just too bad, because I can't really fool around with this anymore. Time is up. But it is really nice. It boots up and all that kind of stuff, and it is responding to... Oh, power off. Hello? Oh, you gotta see this. Of course, I can use the camera, but it's really, really weak because this is... Look at that. No, that is a reflection from the lamp. But before I got this tiny little blue dot, I don't know what I pushed. That gotta be... Where's this light coming from? Ah, you see the problem? This is the infrared rangefinder of my camera that is causing this. Oh man, that is of course a problem. So let's try. Now it's actually in the focus, and then I try and hit the measure button. But there's nothing at all. But it's also way out of range of the camera, so that is just how it is. So probably either the emitter is not working, or I'm just not able to detect it. What I could do is I could actually measure the current of this unit, right? I should get some spikes. Okay, here's what I did. Now I'm powering it up via a resistor. So that means I'll be able to see the current footprint. So if this is the current that it's using, and I set my trigger just below, so I go to normal like this, and then I crank up the trigger level like that, and then I go just down like that, right? And then I hit single. Now I hit the measure button on the unit, and it says laser active, and see what we see here. We actually see a little bit of current change like that. So I mean, I would expect it to use a lot more, but maybe it's only a few milliamps it's using. So I am actually able to detect a little change in current. So yeah, there is a possibility that it's working.